not possible to make an operation amplifier having AO equal to infinity. Practically, the values are varying between this. For 741 op-amp, it is listen. So now that means this is my AO, for example, 10 power 5. This is my 741. Mu A 741. For this one, I am giving plus 10 volts, minus 10 volts, and I am giving two input voltage. This voltage called V2 or V plus.
Yuvraj, please unmute, yeah.
Mute.
Mute. Vignesh.
Sir, I think he's not able to hear. I think maybe from your side you can mute them. That would be better, I guess.
Now, sorry, sir. Sorry
No,
for disturbance.
No issue. Wait. No, don't do it. That is not a big issue.
Sir, shall we break for 5 minutes? Then I will join again.
Yeah, I thought, okay, we can do that. Yeah,
6 o'clock.
10 minutes. It is, 6 o'clock. It is 5:50. 10 minutes, 6 o'clock we join.
It's okay. Roshan.
Hello.
Ah,
Sir, we can start, sir. We
okay,
can start.
Yes, sir, we can start.
fine. Okay, now that we know what is an op-amp, right? How it is symbolically represented, correct? And we will see what are the important specification of a op-amp. We saw that in case of transistor, we see max, correct? IC, max, and also beta. These are important, but please note that if you see a transistor data sheet, you'll have another 10 or 15 per lot of graphs, all those things, 5 to 6 pages for each transistor itself. But these are the important thing we have to note down. And already told you how will you select VCC max, VB max, depending upon what for you are using your transistor, how many voltage you want to amplify, correct? So based on that VCC, VBB, this IC current to be supplied to load resistor. Already we saw the load calculation, all those things. We talked about it. Okay. Similar to that, in case of op-amp also, you are getting signal. What for the amplifier you use? I have a thermocouple, for example, a sensor, right? TC, which measures 0 to 500 degrees centigrade, and it provides 0 to 40 millivolts proportional voltage. This signal need to be amplified to, for example, 0 to 5 volt. Because this signal is very, very low, correct? I want to per degree change, it will be in the microvolts. That voltage cannot be directly given to this one. So that means you have to amplify this one. For that only, we can use transistor as amplifier, or you can use as op-amp. Now, what we are talking here is op-amp. Op-amp, the ideal op-amp, theoretical op-amp. Note down these important points. Whatever you are seeing in this slide also is most important. Whatever telling also are important points. In the exam, it is expected. Not only what you write from these slides, I'm explaining, you take the notes, right? If you want to get the good grades. Okay. Ideal or amplifier, op-amp. These are important. One is called differential gain. Which the AOL. AD means differential gain. In some data sheets, I said it is manufactured by many companies, correct? Philips is making, Motorola is making 741 and operation amplifiers. So they may mention gain of the op-amp called as A subscript D. That means differential gain. It is same as AO is differential gain is called as AD. In some books or some data sheet, it will be AO. AO is an open loop gain. A capital, it is called a voltage. In fact, voltage differential gain. Input is a voltage, output is a voltage. So it is, gain is called output divided by input. In case of transistor, what was input? It was IB, base current. What are the output? IC. So transistor is called as a current amplifier. Generally, we say amplifier. Basically, it is amplifying current. It is called current amplifier. In case of op-amp, it is called a voltage amplifier. We talk in terms of voltage, not in current. In transistor, input current IB, output current beta times IB, which is called IC. That will be supplied to a resistor, load resistor. Then load voltage V0 equal to IC multiplied by RC or RL, load resistor. That's how you do. Here we talk in terms of voltage only. That's why we call a voltage amplifier, voltage gain. It can be represented AOL, open loop gain. Correct? All are same. Different books will mention. Don't get confused. It is called as AOL or AO or AD. Theoretically, it should be infinity. First point. Next thing, there's one more gain also there in case of operational amplifier, which is called as ACM. That is called as common mode gain. The subscript CM says this common mode. Correct? That should be zero. Theoretically, common mode gain should be zero. What it is, we'll see next slide. Then next important point called input impedance of the op-amp. They are called Z-in. In some book, they put R-in. Input resistance. Please note that some data book say R-in. Some book called Z-in. Z means called impedance. R means resistance. Both are almost same. Slight difference is there. Please note that impedance, resistance is a change, but this is how they use. So that value, theoretical op-amp. Theoretically, I want my op-amp should have infinite input impedance. Resistance. It is measured in terms of ohms. Correct? Gain is just a mere number. Correct? Voltage by voltage automatically just number. Correct? There's no units. input gain, the difference gain, these are just numbers. The value I want to be infinity, this should be 0. Then output impedance or op-amp, it is called Z-out, or in some book they put as Z2 also, correct? This is called Z-I, Z-in, correct? R-in. Similarly, they call Z0, Z-out or R0, correct? Output resistance, output impedance. To mention these are different terminology. What should be its value? It should be 0. Then fifth important parameter, bandwidth of the op-amp. What is the frequency it can amplify? Please note that any signal has amplitude, it also frequency. Theoretical op-amp, I want it should be able to amplify any signal whose input frequency varies from 0 to infinite frequency. Correct? That's what you want. These are the most important. This is ideal. Correct? Ideally, I want to become a billionaire. $1 trillion by tomorrow morning. That's my wish as a human. Correct? I want to get a Nobel Prize. Tonight you shall do research, work 24 hours. Next day I get a Nobel Prize. This is human wish. This is all human wish. But it never happens. To get a Nobel Prize, you may work for 30 years, 40 years also research, day and night. To become a billionaire, if you're lucky, you may become a Bill Gates or Elon Musk, something like that. You start an industry. If you are lucky, suddenly within 10 years, you become a billionaire or $100 billion. That is very few, correct? 1 in billion. India, 1.4 billion people. How many billionaires are there? 10 people out of 140 crore people. Correct? That is human wish. I'm just giving an example. This doesn't happen in practically. When I try to develop op-amp, correct? I will be able to get only, this is called practical. Note down. Note down the points. Practical op-amp generally gain value. AOL will vary from 10 power 5 to 10 power 9 or 10 power 10 also. Chances. This is the value. Correct? It may 10 power 5, 10 power 6, 10 power 8, something like that. I told you there are more than 5,000 different op-amp you can buy. Then the common mode gain, I want 0. It is, please note that 10 power minus 5. Correct? That means I say 0.0001, which is approximately 0. But still it is not 0. Correct? Common mode gain, practical amplifier can be 10 power minus 5, 10 power minus 6, something like that. Okay, it is not 0. Okay, then input impedance value, Z-in or R-in will be 10 power 6 to 10 power 12 ohms only, not infinity. Okay, then output impedance, Z-out, I want 0, it will be in the order of 10 ohms to 100 ohms, sometimes even little higher, 500 ohms also. Please note that it can vary. I am giving approximate value only. Input bandwidth, I want infinity. Most of the op-amp have 1 to 20 megahertz. Or worst case, I can get 50 megahertz also, special amplifiers. So these points are very, very important. Okay, ideal, practical. Okay, then next thing is, if I see how you look in the op-amp, correct? Op-amps are generally made as IC, integrated circuit. The 741, this is the 741. Okay, it is a 8-pin IC, correct? It has 8 pins. First pin is what a function of each pin is represented here. They call pin out, they call it. Correct? I view from this one. So this is pin number 1. It is used for offset null. We will see what it is later. That is not very important. Pin number 2 is called as minus. You see that this represents minus. This is called as inverting input. INV means inverting input. That's why it is called as minus symbol. Inverting input is pin number 2. Please note that if I take another IC, correct, op-amp, it may have 8 pins. Okay, and the input may be pin number 3, 4, and output may be 5. Can be, correct? Power supply that can be different. But in case we are talking about most popular, this one US741. Pin number 1 is input null. Input pin number 2 is called inverting input. That is called V minus. Subscript minus. That's what represents the minus symbol. I will tell you what it is next slide. Then other pin is called plus pin, which is connected to pin number 3. Pin number 4 is called minus VSS. I told you VSS minus VSS plus VSS. So pin number 4 you have to carry minus voltage. And pin number 7 represents plus VSS. Here it is represent plus V plus and V minus, right? So there is supply voltage. Pin number 6 is output pin. You can see the already symbol also shown. This is the output pin. And pin number 5 and 1 are called offset. Pin number 8 is called strobe. Right now, you don't worry about it. If you want to know that, you go and see the data sheet. I'm not going to explain. We don't have time. Correct? So, most important pins are supply pins, pin number 7 and pin number 4. And input pin number 2 and pin number 3. Output is pin number 6. So, but it has 8 pin IC. Okay, this is what the 741. If you buy 741 from any company, it will be exactly 8 pin, exactly 7. Each pin is used for this purpose. It will not be changed. So need not worry. Today you buy a Philips and you are using, correct? Suddenly it fails. Tomorrow you're going to market, they say it has only Texas Instrument, TA, but it's 741. You can just buy and insert it. No problem. Okay, it still will work. No, nothing to change because they are all designed same. 741 means all the pins will be same. Any company makes. Next thing, we talked about two things. One is called as differential gain or open loop gain. Other one is called common mode gain. What it is, that's what I'm explaining here. Open loop gain means we know that the operation amplifier, the output voltage V0, note down, V0 equal to AO, correct? AO is open loop gain multiplied by V plus minus V minus. This in my book, here I'm going to say V2. The terminal what I'm using, minus V1. And this is what I'm using, right? But actually, in this one is called, I say V2 is nothing but V plus, V1 is nothing but V minus. Books, they use V subscript plus subscript. Please note that supply voltage given like this, VSS plus VSS or plus V minus V. This is supply voltage. Input voltage always is subscripted in the right side, correct? So this is non-inverting input, plus means non-inverting, minus is inverting input. That I am representing here as V2 and V1 in this case to explain you. Okay. So now, if that means the output voltage V0 for op-amp, any op-amp is AO or AOL times V plus minus V minus, which can be represented as AOL into V2 minus V1. Okay, this is what now what it means is I give, for example, take V1. I am giving a voltage, for example, 1 volt. This is 1 volt. I am giving another power supply. I am taking and giving 2 volts plus minus 2 volts. So what is my V0 now? V0 equal to AOL. For example, AOL for this, I told you it will be 10 power 5 to 10 power 10 also. Theoretical. But understanding purpose, I am giving a small number. AOL equal to 10, for example. For you to understand. Okay. Then I will tell you why it should be high. Later we are going to see. So now AOL, that means AOL equal to 10 multiplied by what is supply this V2? V2 equal to 2 minus V1 equal to 1. So it is going to be 10 into 1. 10 volts will come. What did I supply? Op-amp always amplify differential voltage, which is nothing but V2 minus V1 or V plus minus V. This is called a differential input voltage. Note down. So any op-amp, if you take, it has 2 input terminal. It always finds what is differential voltage, which is called, I can call it a delta V. I can say that V0 equal to AOL multiplied by delta V. What is delta V? Is nothing but V plus minus V0. Sorry, V minus. That's what they do book. In this case, I'm saying V2, V1. Both are said. Don't get nothing to get confused. So if I gave 2 volts here and I gave this one equal to 1 volt, automatically delta V equal to 2 minus 1 equal to delta V equal to 1 volt. Now this is substituted here. This I said 10. So V0 will be 10 volts. Okay. Now instead of that, for example, I give 1 volt here. Plus 1 volt. I am giving plus 2 volt here. Okay. So what is my V0? V0 equal to AOL. I said AOL equal to 10 only still. I have not changed. I already bought the op-amp. So AOL multiplied by V2 minus V1. So it is 10 multiplied by 1 minus 2. that is 10 multiplied by minus 1. You will get minus 10 volts. So my output volt V0 will be minus 10 volts. That is why now you understand if I give. Now, instead of that, I can give like this also. Again, one more clarification. I am giving plus 1 volt here. I am giving 0 volts. What is my output? V0. V0 equal to AOL. Again, AOL equal to 10. Automatically, we'll say that 10 multiplied by 1 minus 0 equal to 10. So I gave a positive voltage, the output is 10 volts. How much? It is multiplied by 10 times. That's why op-amp is called an amplifier. What it amplifies? Input voltage is amplified AOL times. For example, if I take a op-amp having AOL equal 100, this will become 100 volts. That's it. If I give a positive voltage, output will be positive. Instead of that, for example, I am giving a minus voltage. Minus plus, this is 1 volt. This I can give 0 volts. What will be the output voltage? V0 equal to, again, AOL equal to 10. So 10 into, okay, minus 1 volt minus 0 volts. Right? This is minus 1. So it equal to 10 multiplied by minus 1 equal to minus 10 volts. So from this, what you understand? I am keeping this voltage inverting. This is called an inverting input. Note down. This is called as inverting. Wherever minus is called inverting input. This is called as non-inverting input. You know that inversion means 180 degree out of phase, correct? It is non-inverting. So in the non-inverting input, if I give a positive voltage, output will be AOL times that much amplified. Instead of give negative voltage will be multiplied by AOL times. That's why it is called a non-inverting. Whatever the input side, same output will be there, but only it will be multiplied by this one. Instead of that, if I give the non-inverting input, this I connect to permanent ground. I give plus volt, correct? 1 volt. What is my output? AOL multiplied by V2 is 0 minus plus 1 volt. Correct? This is 10 equal to minus 1. So minus 10 volt. So if I give a positive voltage in inverting input, output will be minus voltage. Instead of that, if I give a minus voltage, so I give minus voltage here, 1 volt minus plus, output will be 10 because AOL equal to 10, automatically 10 multiplied by 0, this is connected to 0, V, this is V plus or V2 minus 1 volt, okay, 10 minus into minus plus 1, so you get 10 volts. From this, you understand that in this input, inverting input, if you give a positive output, output will be negative. If I give a negative output, output will be positive. While keeping the other input is 0. Instead of that, if I make this is 0, if I give you a positive voltage, here will be positive. If I give a negative, it will be negative. So that's why this is called as non-inverting input. This is called as inverting input. Okay. This is applicable to all op-amps. Now, other one thing is what you called as the output is always V2 minus V1. That is what is amplified. One thing. Now we talked about open loop gain. Open loop gain means I am giving 1 volt here. I am giving 2 volts here. Okay. This AOL equal to 10. Okay. Now, according to this one, AD or which is called AOL or AO, these are the different terminology equal to. I gave some two inputs. The difference, this is delta V. And I am getting some output. For example, I am getting output 10 volts. Correct? What is the difference voltage? 2 minus 1. That is 10 divided by 1. What is my AD? AD equal to 10. Since the output signal is amplified, difference of these two, that's why this is called differential gain. Instead of that, if I take the op-amp, I short circuit both the input, inverting and non-inverting connected. I am giving a common voltage. For example, I am giving from battery 1 volt, correct? Plus 1 volt. What happens? V2, this is V2, this is V1. V1 equal to V2 equal to 1 volt. Then what happens? The common mode gain, that means when both the voltages equal, same voltage exactly give, you are getting some output, correct? So what will be AD? AD, this voltage will be 0. If I give both equal to 1 volt, what will happen? This will be 0. Here, will be 0, correct? So it should be infinity. Theoretically saying, it should be infinity. Both you are giving same voltage, differential gain will be infinity, theoretically, correct? That's why theoretical op-amp will have a differential gain will be infinity. Okay, when both are equal, inputs are the different delta equal to 0 and output will be 0. 0 divided by 0 infinity. But that is not happening in the practical. That's different. ACM is that when I short circuit both the input same voltage, output voltage should be theoretically 0. But sometimes in op-amp, you will get some millivolts or microvolts. Correct? You will get microvolts when input equals 0. Correct? So that's why this is called as common mode gain. Correct? What I want theoretically, this should be 0. ACM should be 0. But practically, it will be 10 power minus 5, 10 power minus 6, something like that. That's what it is. Then another terminology, what will come across op-amp is CMMR. Note down, it is called as common mode rejection ratio. That's what called as CMMR. Is nothing but AD divided by ACM. This is called AD or AOL or AO because this is terminal same thing, correct? Divided, this is called CMMR. Okay, this should be very high. This should be very high. We know that. What is my practical op-amp AD or AOL? I said 10 power 6. For example, 741. What was the ADCM for this one? ADCM was something minus somewhere we saw very small value. Yeah, here 10 power minus 5. Correct? So I say 10 power minus 5. So equal to CMMR for 741 equal to this goes up 10 power 11. Correct? This is better. But basically what I want, if this is infinity, this is 0, if CMR will be infinity. Correct? That's what I want theoretically. Practically not possible. Okay. Now that you understood. Now, what is inside my op-amp? Okay. We are talking also op-amp. What is inside? Inside op-amp, you have same transistor only. Amplification is done only by transistors. Without transistor, you cannot amplify. Only thing is, it has many transistors connected in only a single IC. It is called integrated circuit, in which you can see that this is 741 internal architecture. There are Q1 one transistor, Q2, 3, 4, 5, 6, 7, 8. Inside that, there are 7 transistors connected in what you call as cascaded connection or serially connected transistor amplifiers. Already we saw the common emitter amplifier. So you can see that inside that there are 8 transistors and they have resistors also. This is RC. This is RC. Correct? This is RB. Right? Like that, you have resistors also. All these things are made in a single silicon where we call integrated circuit, but it consists of 7 transistors. Each transistor works as a common emitter amplifier. Sometimes as a common base also. There are. So now, what you can see that in this stage, this part is exploded for you to understand. This is called a differential amplifier, no doubt. Correct? Already written here. It is called as different input stage. This is called the input stage of the op-amp. This is called the output stage of the op-amp. In between, this is called intermediate gain stages. Correct? So this is cascader means I take one transistor like this common emitter amplifier. This is my RB. I give my input signal here, V in. Correct? So there's my IB. Because of that, there's a current flowing. This is my this one collector. IC current is flowing here. Okay. Take this output, give it to one more transistor. This is the emitter. This is the RB2. This is RB1. This is, I call this as, this is supply voltage. Okay. Plus minus VCC. Okay. Then this is RB2. This is called RC2. Again, supply voltage. Then take the output, give it to one more stage. Like this. I give the input here because of this IB. this has a beta, for example, 100. All the transistor has beta equal to 100. You take it, correct? I say that 3-stage amplifier, common emitter, connected like this, supply voltage. This is my RC3. This is RB3, correct? So finally take output. This is my V0. Okay. Each has a 100 gain. Beta equal to 100. This also beta equal to 100. Okay. Now I give the input here. I am taking output 3 after 3-stage amplification using 3 transistors. Correct. This is called as cascaded connection or serial connection. Inside amplifier, that is what is there inside op-amp. In this case, you have 5 stages. This is called first stage. This is called the second stage. This is called third stage. This is called fourth stage. This is fifth stage. Correct. But you can see that there are sometimes 2 transistors are there. Don't worry about that. But think that there are 5 stages. Each I'm giving input here. I call this a beta 1. I call this beta 2. The beta 3. I know that totally this is 100. This is 100. This is also 100. What is the total beta? Beta equal to of the total amplifier. 3-stage cascade amplifier is beta 1 multiplied by beta 2 multiplied by beta 3 is the total amplification, current amplification factor of this transistor amplifier. Inside the op-amp also it is same. Okay. But I told you just to some half an hour before, Fairchild Corporation invented open op-amp to mitigate what is that change in beta due to temperature. Right? If temperature beta increases, temperature decreases. Because of that, my IC also varying, even though my IB is constant. Input current is constant, my IB is varying due to temperature. And now to solve this problem only they call the temperature drift, I told you, correct? Temperature drift in transistor amplifier. There is a major drawback. Okay. To avoid that only, Fairchild invented the op-amp. But inside op-amp, again, you have the same CE configuration, but only the multiple stages are there. Correct? So that means if temperature of op-amp itself, correct? Temperature of op-amp was 30 degree. At that time, this gain was 100, 100, 100. What is total gain? 5 stages there. 100, 100, again 100, again 100, finally is 100. According to total beta equal to, I say this is beta 1, beta 2 like this, beta 1 multiplied by like this, beta 5. Each equal 100 equal to 10 power 10. Correct? So that is what we call AD, note down. Because inside my op-amp, I have multi-stage common emitter transistor. Generally, apart from that, there are transistor amplifiers, common collector and common base. Correct? CC and CB. Okay. Inside this also it is there, but you don't worry about that right now. Okay. You think that for understanding purpose, we cannot go deeper. That is not our interest. We are going to use just op-amp as a block diagram. Correct. By the IC, this is we are not going to worry about at all. None of our business. So, but only thing we want to understand what it is. For that only we are talking about it. Now, since it has 5 stages, each stage 100 gain. Correct. Beta for each transistor. I said 100. For example, first maybe a 10, second maybe 1000, third maybe have a 10, fourth maybe 100. Anything it can be. But finally, what is it? Multiplication, all those things. For understanding purpose, I said all 5 are equal gain, current gain, transistor inside the op-amp. So in this case, 10 power 10, correct? So this is what we call as AOL or AD, correct? Basically what I want infinity, but not possible. That's why the practical op-amp has 10 power 6 to 10 power 10 only. It may be 5 stage, 6 stage only. Not if I want infinite, what you should have? Infinite amount of the C amplifier connected in series. Not possible. So we have only this stage. You got it? Any doubt in this? I can just clarify. Okay, that's one thing. Okay, next thing is the input stage of op-amp is called a differential amplifier. Correct? Differential amplifier means you can see that I can divide this in 2 parts. This is my input and this is my output. What is this? Common, you can see the one, this is my emitter, this is my collector, this is my base. This is network common emitter amplifier, correct? This is one stage. Similarly, right side also, you have base emitter, this is one more common. Now what I do, I connected both common this is first one, the second one together and having common VCC. But note down what is the important thing. RC is separate, collector this one, here also separate. Correct? Base I am giving separate voltage. Here also base I am giving, so different base current IB can go depending upon if I connect like this. Power supply, this is my RB. Similarly, RB power supply, this is VBB. The VBB only what we call V1, V2. Correct? So what I am saying is VBB for the base is nothing but V. I call V plus and V minus. Correct? You can see the V in minus, V in plus. One transistor. So this is, and I have common emitter resistance. Already we saw emitter resistance in case of transistor amplifier. Correct? RE. So here for each transistor we need a RE. Instead of that, in differential amplifier, I am having a common RE. One resistor through which both the IE, this is called emitter current 2, I call emitter current 1. Both will be added, goes to minus power supply. Plus power supply is given to the collector. So this is called a different. The advantage is if I use this, one is called V plus, other one is V minus, which is called as inverting input. Other one is called non-inverting input. Correct? So this is called as non-inverting input. Okay. So then the output from the first stage is this. This will be given to next stage. You can see that from here it is given to next stage. So the advantage of this is it removes noise. Noise is eliminated if I use differential amplifier. That's why op-amp has two inputs and the first stage consists of a differential amplifier. Common emitter differential amplifier, which removes automatic noise cancellation. Correct? It is called as automatic. No doubt, this is important point of differential amplifier. Only thing is my sensor should be connected between these two inputs. For example, this is my thermocouple. Thermocouple has plus terminal, minus terminal. It is one is connected to. Okay, I can connect like this, plus minus. Thermocouple positive, correct, is connected to V in plus non-inverting, and thermocouple minus terminal connected to inverting terminal. Okay, now I connected as a differential. So if thermocouple picks up the noise also, the noise, EMI noise, correct? Sensor can pick up EMI noise, that will be automatically cancelled in the output, automatically be cancelled. That is advantage of differential amplifier. So that is the plus point of op-amp. Any doubts? Okay. Now, this is op-amp. As I told you already, we discussed. We give input voltage to both through one power supply. This is called as V1 and plus minus. I'm giving 2 volts and I'm giving here plus minus. This is V2. It is connected to non-inverting input. This is called as inverting. Note down. In the exam, if you make mistake, you lose mark. Correct? That's why I'm repeating. So connected like this. So this I call V2. What is the output V0? I say AOL equal to 10. But I know that the 10 power 6, 10 power for understanding why I'm always keeping big small number. Okay, we'll see that. V0 equal to AOL times V2 minus V1. Okay. So in that case, we know that 10 into 2. This is, I told this is 3 volts. Correct? 3 volts minus 2 volt equal to 10 into 1. 10 volt will be output voltage. Correct? This is called as open loop configuration. Correct? My op-amp, I have op-amp. Input, there are two input. Both input are giving two different voltage. The difference voltage delta V is will amplify AOL times and output will come. This configuration is called as open loop configuration because that one thing. And the main problem with this is the AOL is temperature dependent. Please note that AOL is temperature dependent, just like beta. AOL is temperature dependent, just like beta. Why? Inside the op-amp also I have this one. Then what is use of making the op-amp? So somebody may ask question, correct? So if I use my op-amp in open loop configuration, this problem persists. If temperature changes, AOL, I said 10 power 6 or 10 power 7 or 10 power 8. This will change. This is at particular temperature, 30 degree. If temperature is 45, it may become 10 power 7. It can vary a little more. Correct? 10 power 6 is 1 million. It may be 1 million 1,000, 1 million 10,000. It varies. Automatically, that number is so. That is a problem. So if I use my op-amp in open loop configuration, the thermal drift of the output of the op-amp, what we call thermal drift, just like transistor, is not this one. So I cannot use my op-amp in open loop configuration. But if I use, I have to maintain temperature. Temperature should be kept constant when I use my circuit op-amp as an open loop amplifier. They call it open loop configuration or amplifier. Another drawback is we know that my AOL equal 10 power 6. For example, here generally it goes 10 power 8. Okay, what is the maximum input voltage I can give? Another note down, my output voltage V0 cannot be greater than VSS. Correct? If I say 10 volts plus, 10 volts minus, the output voltage can be plus or minus only. It cannot be greater than that. Okay. Now, because of that, there's a problem. My AOI is 10 power 6. I am giving, for example, inverting input 1 volt. Non-inverting input, I am giving 2 volts. This is one, correct? So now, what will happen? The difference equal to 2 minus 1, 1 multiplied by 10 power 6 volts. Correct? It equal to 10 power 6 volts, my V0. But I told you what is supply voltage I can give? Plus or minus 3 volts to plus or minus 18 volts only. You cannot give, there are special amplifiers which can be 100 volt, 500 generally. Now, that means what will happen? The op-amp cannot produce 10 power 6 volts. It will give plus supply voltage 10 volts only. Correct? If the difference is this is 2 volts, this is 1 volt, you are supposed to get minus 10 volts, minus 10 power 6 volts. Instead of that, op-amp will give minus 10 volts only. We call this saturation. Correct? So op-amp, even if the differential voltage delta V is in the order of microvolts, correct? Output will be in the order of volts. Why? If I say that I am giving 10 microvolts here, correct? This is 20 microvolts. Okay, we know that what is delta V? 20 minus 10 equal to 10 microvolts equal to 10 into 10 power minus 6. Micro means this one. Multiplied by my AOL. What is AOL value? 10 power 6. Correct? What happens? 10 power 6 plus and minus gone. I will get 10 volts. V0 equal to 10 volts. This is okay. Instead of that, for example, this is 30 microvolts. Correct? If it is 30 microvolts, what will happen? In this case, you will get 10 power 6 AOL multiplied difference is 20 into 10 power minus 6. Correct? Minus 6, this is my V0. So this is gone. Output is 20 volts. But my supply voltage is 10 volts. Output will remain 10 volts. So I say my output is saturated. So from this, what you understand? My input voltage in open loop configuration generally limited to microvolts, nanovolts only. If my sensor output, for example, I have a sensor, temperature sensor, if temperature varying 0 to 500 degree, correct, centigrade, my sensor should produce 0 to maybe 10 microvolts only. If my AOL equal to 10 power 6 and the supply voltage plus 10 minus 10 volts, correct? So that V0 will not saturate, will not saturate. Saturate means it will be amplified, the exact output. This time should be multiplied, correct? If the voltage exists beyond this, I cannot use this amplifier. But I want AOL, most of practical amplifiers, AOL 10%, 10 power 10 also. Theoretically, I want AOL equal to infinity, right? If infinity means even 0 volts, output will be infinity. What do you use? So open loop amplification is very limited, except you have microvolts, nanovolts, you want to amplify, you can use open loop configuration. Okay. But in spite of that, it has the temperature, the AOL will vary with respect to temperature. The temperature drift will be there even in this case. If you want to avoid, you have to go what you call as amplifier, operation amplifier with negative feedback. Okay. Note down the circuit, important. Okay. All the operation amplifiers in the open loop kind of very limited use. Generally, they don't use. Because one thing is very small signal itself will amplify, get saturated. Second one is the AOL changes with respect to temperature in open loop configuration. I want to get rid of the AOL in my output formula. For that, I go what you call as operation amplifier with negative feedback. So this is the operation amplifier, correct? You can take any operation amplifier. I'm taking 741. It has 5 pins, important remaining 3 pins I am now ignoring. So V plus supply pin number 7, V minus supply pin number 4, pin number 6 is output, pin number 2 is inverting input marked as minus, pin number 3 is non-inverting input marked as plus. Please see that now additionally I have 2 resistors. This is the externals of what I'm using. This is my IC 741. I bought it. Apart from that, this one, I used the power supply. I gave input signal. That's it. But in case of operation amplifier with negative feedback, what is use of this? This eliminates. Which eliminates negative feedback? Eliminates the output voltage dependency. Note down output voltage dependency on AOL and op-amp of op-amp. Okay, that is my if output voltage. We are going to see that how it works. So let me clear this. Take down the picture. In the exam, you may be asked to draw the operation amplifier with negative feedback, derive the output voltage gain, operation output gain, which is called as feedback gain, which are called as AF. AF is called as feedback gain. Note down. What was AO or AD is called as open loop gain. Open loop gain of op-amp is decided by the manufacturer. You can't do anything. If I buy 741, it is 10 power 5 or 10 power 6. If I buy something else 7447, something 747, correct? It may be, for example, 10 power 8. This is fixed by manufacturer. You cannot change it. But you can modify feedback and AF with negative feedback, which is called as represent AF, by modifying the resistance value of these 2 resistors. Correct? Modifying these 2 resistance value ratio, I can change the feedback gain, which is represent AF. Correct? So how it is done? AF equal to, correct? AY equal to, we know that feedback gain. What is gain? Gain equal to output divided by input. I am giving input voltage here. This is my sensor. For example, thermocouple TC. This is my sensor. Correct? Sensor is 0 to 500 degree centigrade temperature changes. It will 0 to 100 millivolts. This is my sensor. This needs to be amplified 0 to 5 volts. Correct? In millivolts, 0 to 100 millivolts. Represent this one. This to be amplified 0 to 5 volts. For that, I am using operation amplifier with negative feedback. So the circuit is this. Okay. Now let me remove this. My sensor. Understand this result. So input is given here. Output is taken here. What is my gain? This is operation amplifier with negative feedback. That means you need 2 resistors connected like this. One resistor is called feedback. RF is called feedback resistance, which is called a RF. The subscript F's represent feedback, but I can say R3 also. Nobody can question. I can say R2 also. But only thing is, it should be connected between output of the op-amp to the inverting input of the op-amp. In this case, pin number 2 is the 74. You can see that this is connected. This resistor RF. Then one more resistor is there, which I call a R1, which is connected between inverting input to the ground. This is ground. In correct, ground equal 0 volts. Disconnected. So this circuit is called as feedback network. Feedback network. These 2 resistor connection, connected output is the input connected to ground like this. From the center point, I given to this. This is called a feedback network. The feedback now in operation amplifier, the output voltage is decided by these 2 resistors only. That's what we are trying to prove. Okay. V naught equal to V in, AF equal to V naught divided by V in can be represented as AOL divided by 1 plus AOL into beta. What is beta? Beta is called a R1 divided by R1 plus RF. What is R1? This is RF. This is RF. Correct? R1 divided by R1 plus RF is called beta. And what is AOL? Open loop gain. my AOL equal to, for example, mu 741 10 power 6. So that means I can write this equal to 10 power 6 divided by 1 plus 10 power 6 multiplied by beta. Okay, that is my AF. Okay, please see that still in the formula AOL is there. I have given negative feedback. I told you just now, if I give negative feedback, I can get rid of AOL, which is temperature different. So now this is new gain, which is controlled better. That will happen only when AOL is very large. AOL is very large. That's what I'm trying to prove. The derivation, note down the derivation, very important derivation. Okay. Okay. Yeah, good. Now, what is beta already know? Now I substitute this. Beta I know formula. Okay. I can return AF equal to AOL divided by 1 is coming here. My AOL is here. Beta is R1 divided by this one. I can expand it to AOL into R1 into RF divided by R1 plus RF is this one. This is what now my AF. Okay. Now, most important thing I told you, my AOL is large. Correct? AOL equal to 10 power 6 or AOL equal to 10 power 10 or AOL equal to 10 power 8. What happens? In the denominator of the above derivation, this part. Correct? For example, I say that this resistance value equal to 1000 ohms. We are going to decide how much it should be later. This is, for example, 2000 ohms. Okay, I write this is 2000 ohms. This is 1000 ohms. I will. There's a reason for that, no doubt. Okay. Now I substitute that on my AOL equal 10 power 6. Correct. In this formula, if substitute what happens, 10 power 6 multiplied by R1. R1 is 1000 ohms. Correct. RF is 2000 ohms divided by 1000 plus 2000 plus AOL equal to 10. Sorry. AOL equal to 10 power 6 multiplied by R1. R1 is 1000. This term. So, which will become numerator 10 power 6 into 3000. Denominator 1000 plus 2000. Correct? 3000 plus 10 power 6 into 10 power 1000 is 10 power 3. This will become 10 power 9. Correct? Now, compared to 10 power 9, correct? 10 power 9, correct? 10 followed by 1 followed by 9 zeros. This is just near 3000. Can I ignore? Compared to this, very, very small, I can ignore. Correct? So that means in that case, what will happen? These two parts can be ignored. Correct? Only when this is very, very large. AOL multiplied by R1 is very, very large. Compared to these, my denominator can become AOL to this one. I ignored this part. I maintain only this. So AOL in this one. So I can expand this is the AOL goes, then my AF equal to R1 plus RF divided by R1, which can be nothing but 1 divided by beta. What is beta? Feedback gain network. Correct? Gain of the feedback network. Gain of feedback network is beta. That is 1 over beta. That means you can see that now my AF is free from AOL. Correct? So what is my output? My output equal to V0 equal to, now I can write V0 equal to AF into V in. Correct? In my AF formula, do you see AOL? No. I can ignore AOL only when AOL is greater. Correct? If it is infinity, better. But as the bigger the number, this part can, please note that this part is ignored. Still it is there, but only the value is very small. For example, this value is 10,000. Correct? This equal to, for example, 2,000. Correct? Still it is 12,000 only. This joint value is to 12,000 only. Still this is 10 power 6 multiplied by 2,000. Still the value is bigger. Instead of that, I take another op-amp which has 10 power 8. That is 10 power into 2000. This is going to be 12,000 only. So I can always ignore. If I give negative feedback from this derivation, what you understand? If I give the negative feedback by using this network, my output voltage is decided by AF, not by AOL. AOL is not there in this formula. So I have made my operation amplifier. It is going to amplify. Please note the amplification done by AOL by the op-amp only. That depends on AOL, but it is not this one. It automatically cancels out. In numerator, denominator, both the place it is there. Automatically cancel. It is decided only two resistors. The ratio of these two resistors. That means AF equal to 1 plus, this is a constant, RF divided by R1. Correct? For example, AF I want 10. Gain equal 10. For example, please note that forget about AOL now. Now you are going to feedback gain. I want amplify the V in. For example, this is given 0 to 100 millivolts. I wanted to amplify to 0 to 1 volt. That is 1000 millivolts. What I want? I want this gain equal 10 times. Correct? 0 means 0, 100 millivolts, 1000 millivolts. 10 times I want to amplify. So AF should be 1 plus R of this one. 1 plus RF divided by R1. Now, there is two variables. What I do, one variable I can assume. I can say 10 equal to 1 plus RF I decided 2000 divided by R1. So you can find out R1. So R1 equal to 10 minus 1, right? Divided by RF. Okay. So you can find out what is the value that now you are designed by operation amplifier. This one. This is how operation amplifier with negative feedback eliminates the dependency of AOL. Automatically, the variation output voltage due to temperature is avoided. But if you use open loop, this benefit is not available. That's why you use this. I can, if I want gain equal 1000, I want a 0 to 10, say for 100 microvolts is coming my sensor from a special sensor. I want to 0 to 5 volts. What I have to do? My gain, AF equal, how will you find the AF? AF equal to maximum output voltage wanted, maximum input voltage. V naught divided by V naught maximum divided by V in max. So that equal to AF equal to 5 volts is nothing but 5 into 10 power 6 microvolts divided by 100. Correct? So that means this will become equal to my AF equal to 5 into 10 power 4. Okay. Now 5 into 10 power 4 equal to 1 plus RF divided by R1. I can decide RF equal to some resistance value. For example, I take this 10,000. Right? So I can compute R1. So I will find R1. I have designed my amplifier. Any doubts? Okay. I wanted to close it. I know it is almost 7 o'clock. I'll just complete with this one slide. Correct? What is the advantage of negative feedback? Note down important points. See, whatever I'm talking on is very important for NSM exam. So don't miss the classes. Just don't log in and just go away. If you don't take notes, all those things, you lose your NSM marks. Because all the classes are very important. I'm talking very, very important for mechatronics. Everything is important, but this is also very important. Okay. So main advantage of negative feedback is it increases input impedance of the op-amp and reduces output impedance of the op-amp. No doubt. Then if I give negative feedback to op-amp, it increases bandwidth. Okay. Bandwidth nothing but what is the frequency from 0 to up to what frequency amplifier can amplify? 0 to 1 megahertz, 0 to 20 megahertz, 0 to 50 megahertz. That can be increased. Please note that open. Later I'm going to show the formulas next to this one. Already input impedance op-amp is high. What we saw, just 2 minutes ago, because what we saw, it varies from 10 power 6 to 10 power 12. Okay. For example, if I take 741, Z10 equal to 10 power 6. This is an open loop. If I give negative feedback, this will be multiplied by AOL into beta. Note down. Z10 open loop condition is 10 power. That is very good. I want infinity, but not possible. I got it. I just gave negative feedback. I did not do anything. Took this one and now it is amplified AOL times beta. My AOL is 10 power 6. Correct? My beta is another feedback gain. Feedback gain is 10. I want to amplify 10 times. So what happened? 10 power 6 multiplied by 10 power 6 multiplied by 10 power 1. So my Z10 is increased 7-fold. 10 power 6 multiplied by 10 power 7-fold. Correct? So that is better. So negative feedback helps in increasing the input impedance. That is what I'm talking. Okay, it increases input impedance and it reduces output impedance. Z0, I said Z0 equal to 10 power minus 5 in open loop condition, correct? With negative feedback, I say that with feedback, Z2F, I call it. I call this Z in F with negative feedback is nothing but Z in multiplied by 1 plus AOL time beta. Note down this formula. The original Z in 10 power 6. AOL 10 power 6. Beta equal 10. This was AF you decided. Correct? Beta is nothing AF. Correct? Now, that may increase. Similarly, the Z0 should be 0, but practical 10 power minus 5 ohms. That is micro ohms. But if I give negative feedback, automatically what will happen is Z0 divided by AOL time beta. It will be still reduced. You can see now division. This is another advantage. Beta, I said increases. That is gain bandwidth. BW, I say that 5 megahertz. If I give negative feedback, it may increase more. Correct? How much it is, there's a formula I will show that. It rejects external disturbances due to noise. Correct? Open loop doesn't do here. Temperature dependence is removed, noise is removed, and it also further amplifies any variation in parameters. Op-amp also is taken care. It rejects all these things. So if you give 10 millivolts, AF equal 10, output be 100 millivolts. Whether 30 degree, 50 degree, 60 degree, as long as with you operate your op-amp within the operational range, if temperature varies also, is not going to affect. So that is the main thing. Then gain is dependent only on the two external feedback network. What this? These two resistors only going to design my AF, not my AOL. Very important. Okay. Last thing is it reduces signal distortion. These are the important 5 to 6 point. Note down. I stop here. Monday we'll continue with op-amp and filters, amplifiers and filters. Basic you understood. You can quickly go through different type of operation amplifier like inverting amplifier, non-inverting and instrumentation amplifier. And also we talk about filters, low pass filter, high pass filter to remove noise using operation amplifier. That's what we are going to see Monday. Thank you very much. See you on Monday. Have a nice weekend. Any doubts I can clarify if you want. Hello. Okay, no doubts, I will just close. Your attendance without forgetting. சொல்லுங்க ரசனம். குட் ஈவினிங் சொல்லுங்க. ஓகே 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 ஓகே. இல்ல இன்பிட்வீன் யாரோ பேசிட்டாங்க, ரெண்டு மூணு மாறி மாறி பேசிட்டாங்க, அதுக்காக தான். ஓகே, நோ இஷ்யூ நோ இஷ்யூ. ஓகே, see you on Monday சொல்லிடுங்க எல்லாருக்கும். தேங்க்யூ.